Strange form of ice found that only melts at extremely hot temperatures. Odd things happen inside planets where familiar materials are subjected to extreme pressures and heat. Iron atoms probably dance within Earth's solid inner core, and hot black heavy ice, that's both solid and liquid at the same time, likely forms within the water-rich gas giants Uranus and Neptune. 5 years ago, scientists recreated this exotic ice, called superionic ice, for the first time in lab experiments, and 4 years ago, they confirmed its existence and crystalline structure. Then just last year, researchers at several universities in the United States and Stanford Linear Accelerator Center Laboratory in California, SLAC, discovered a new phase of superionic ice. Their discovery deepens our understanding as to why Uranus and Neptune have such off-kilter magnetic fields with multiple poles. From our early earthly surrounds, you'd be forgiven for thinking water is a simple elbow-shaped molecule made up of one oxygen atom linked to two hydrogen and settle into a fixed position when water freezes. Superionic ice is strangely different, and yet it may be among the most abundant forms of water in the universe, presumed to fill not only the interiors of Uranus and Neptune, but also similar exoplanets. These planets have extreme pressure of 2 million times the Earth's atmosphere, and interiors as hot as the surface of the Sun, which is where water gets weird. Scientists confirmed in 2019 what physicists had predicted back in 1988, a structure where the oxygen atom is superionic ice and locked in a solid cube lattice, while the ionized hydrogen atoms are let loose, flowing through that lattice like electrons through metals. This gives superionic ice its conductive properties, and it also raises its melting point such that the frozen water remains solid at blistering temperatures. In this latest study, physicist Ariana Gleason of Stanford University and colleagues bombarded thin slivers of water sandwiched between two diamond layers with some ridiculously powerful lasers. Successive shock waves raised the pressure to 200 GPa, that's 2 million atmospheres, and temperatures up to about 5,000 Kelvin, that's 8,500 degrees Fahrenheit, hotter than the temperatures of the 2019 experiments, but at lower pressures. Recent discoveries of water-rich Neptune-like exoplanets require a more detailed understanding of the phase diagram of water at pressure-temperature conditions relevant to their planetary interiors, Gleason and colleagues explained in their paper. X-ray diffraction then revealed the hot, dense ice's crystal structure, despite the pressure and temperature conditions only being maintained for a fraction of a second. The resulting diffraction patterns confirmed the ice crystals were in fact a new phase distinct from superionic ice observed in 2019. The newly discovered superionic ice, Ice 19, has a body-centered cubic structure and increased conductivity compared to its predecessor from 2019, Ice 18. Conductivity is important here because moving charged particles generate magnetic fields. This is the basis of dynamo theory, which describes how churning conductive fields, such as Earth's mantle or inside another celestial body, give rise to magnetic fields. If more of a Neptune-like ice giant's insides were taken up by the mushy solid and less by swirling liquid, then it would change the kind of magnetic field produced. And if towards its core that planet had two superionic layers of differing conductivity, as Gleason and colleagues suggest, Neptune might contain, then the magnetic field generated by outer liquid layers would interact with each of them differently, making things stranger still. Gleason and colleagues conclude the enhanced conductivity of a layer of superionic ice akin to Ice 19 would promote the generation of wonky, multipolar magnetic fields like those emanating from Uranus and Neptune. If so, it would be a satisfying result more than 30 years after NASA's Voyager 2 space probe, launched in 1977, flew by our solar system's two ice giants and measured their highly unusual magnetic fields. And this study was published in Scientific Reports. This is on Science Alert by Claire Watson. Please leave your comments and thank you for your support. Please support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box below.